Team is back with another episode of Topical Explainers for the fourth chapter of CAIE Ace Level Pure 1 Mathematics. In this video, we will be discussing all about circle measure, and to simplify the topic and provide us with all the information we need, we have Pratyush here with us.
Hey guys, welcome to Chapter 4, Circular Measure. Today we're going to be covering radians, arc length, sector area, and the trigonometry rules. This chapter is a short one. It's going to be mostly about circle measure, as the topic suggests. So that includes a lot of angle stuff. So you need to know your basic trigonometry rules from the previous years. And you're going to need to know some terms relating to circles, such as the arc, the sector circle, that's a sector, the length is the arc, diameter, across, radius, that much, etc. And ideally, you should have completed previous chapters, but it's not a hard requirement on this chapter. You can probably do it on your own without the other chapters, but still good to know previous. So this chapter, the only new thing that we will be learning is the radian. And this is a measure of angle, which is derived from, as the name suggests, the radius of a circle. The way we define a radian is we take a circle, as shown in this diagram. From the center, we measure out an arc of length 1 radius, and we call the angle subtended at the center. Subtended means formed when you bring lines together. This angle here, theta, is equal to 1 radian, because these both are 1 radius, as you see here, 1 radian. This definition is quite useful, actually, comes in other subjects as well. The radian is an interesting thing because it simplifies a lot of circular calculations. And we'll see what that means later on. But for now, here's some interesting facts. Now, due to the property that it's based on the arc length, and a circle, if you count the whole arc length, which means its circumference, if you take the whole circle's arc length, it's just the circumference, right? And the circumference is equal to 2 pi r. You should know this. And since 2 pi radiuses fit on our circumference, the whole circle, if you take the whole circle, it's take the arc length all the way around it, you see. That is equal to the angle, 360 degrees, is equal to 2 pi radians. I'm not sure if that is very clear, but it'll be more understood as we move on. And if 360 degrees is 2 pi radians, so the whole circle, 360 degrees, is equal to 2 pi radians, then 1 pi is equal to half the circle, right? So 180 degrees is equal to pi radians. One interesting thing to note here is that radians actually don't have a unit. You see here, if you write 360 degrees, you have to include that little degree sign. However, if you write, let's say, pi radians, there's no requirement to write radians. Questions will often include rad, just to make sure you don't get confused with degrees, which is unlikely because radians are, they usually have something strange to tell the difference. However, you don't have to have a unit because it's simply the ratio of arc length to radius length. And since it's just a ratio of length to length, they cancel and it's just a number with no attachment to it. And they're super important for problems relating to circles, such as circular motion in physics, because they turn something that looks like this angle over 360 times 2 pi equals arc length s into something that looks more like this angle times radius equals this. See, that's a big difference. Now we'll see what that means in the next slide. So before we do any calculations with radians, we need to know how to convert between radians and degrees. Degrees you are familiar with, but radians, we're going to first look at how we convert between the two. To convert from degrees to radians, given our definition of radians, simply multiply by 2 pi. So if 360 degrees equals 2 pi radians, right? Just know the identity and you can derive the rest. Then you can say, hey, let's divide both sides by 2 pi. 360 degrees divided by 2 pi is equal to 1 radian. So if you're converting from 1 radian into degrees, you're going to multiply by 360 by 2 pi, or you could simply half both top and bottom. Look at that. And if we're going to go the other way, 360 degrees equals 2 pi. Hey, what's 1 degree? Divide by 360. 1 degree is equal to 2 pi divided by 360 radians. So that'll take us from this many radians is 1 degree. Oh, wait, wrong way. Take us from how many degrees is 1 radian? That's the top one here. So I'm just going to erase this now that we know. Here's some few questions. So let's apply our first formula, convert from degrees to radians. Let's use this one here. Let's multiply this by 2 pi times 2 pi divided by 360. And I'm going to use my calculator here. 225 divided by 360 times 2 pi. You know, hopefully you know where the pi is on your calculator. And that gives us 5 over 4 pi radians. You don't have to write radians, but it helps to distinguish between the two. You can also write that as 5 pi over 4 equivalent forms. Now for 100, let's see that. Same idea, times 2 pi over 360. Actually, for this one, let's do A180 just to show it's the same. Times pi divided 180 equals 100 over 180, 5 by 9 pi. Awesome. And now to convert from degrees, we're going to do this formula. Multiply by 360, divide by 2 pi. So what's that? Let's divide by 2 pi first. And that gives us 5 over 12 times 360. Or you could just plug the formula like we did before. Times 360 divide 2 pi equals 150 degrees. Cool. And wait, what about this one? There's no pi attached to it, but it's the same formula. 1.25 radians times 360 over 2 pi is equal to 1.25 times 360 over 2 pi equal to, well, it's a irrational number because there's no solid multiple, but I'm going to round it to that. But if you wanted to keep going, it's like 1972439, But I'm just gonna stop at 7.16. That's 3SF. Okay, one other cool trick that I keep in mind is I just think 1 pi is equal to 180 degrees. What does that mean? Well, if I have pi radians, that's 180 degrees. So if I see something like 4 by 5 pi, I just turn that pi into degrees. So 4 times 180 degrees over 5. Okay, what's that? 4 over 5 times 180, 144 degrees. This is an important thing. It's mostly common sense once you remember that either 360 is 2 pi or 180 degrees equals pi rad. I like to remember this simpler. If we know this, we can mostly do the rest of the chapter. So let's continue forth. And now this is one of the two formulas you need to know. Arc length formula. As you've done in previous chapters without radians, if you have a circle and you want an arc with, theta, then you know that the whole circumference is 2 pi r, right? The radius. And then if you want like a slice of it, like a slice of pi, then you're going to do the angle out of the whole pi, 360 degree. But thanks to the properties of our radian, where a degree is equal to 2 pi over 360, this actually cancels it out. Well, let's see. If we put in, instead of degrees, if we convert this degree to radians, we'll see that the pi over 360, cancels. Did I write that right? I think I flipped it here. Yo, can you check this?
Yeah.
Is this right? Wait, let's see the previous slide. Degrees to radians. Oh, that's right.
That is correct. Yeah, it should be like that.
Okay.
Wait. Oh, I used to always do it as like pi upon 180 degrees. That's why I was like confused. Why is it 2 pi? But anyways, I think it should be fine.
Okay, so if 1 radian. Okay, so let's get back to how we end up with this. If we have this, and I'm going to replace this degrees with this radians, then it's gonna look something like this. Pi angle times 2 pi, angle in degrees, by the way, times 2 pi over 360, and then we just have the times radius. And you see this, the radian definition. This is a radian definition, right? This has taken out about this much of our formula for us. So it's, if you see well, oh my gosh, my brain is not working today. Okay, so the definition for the radian actually does most of what this formula does. That this times 2 pi divided by 360. This is a radian, right? This is a radian. And if we just multiply radian by r, voila, would you look at that? We have the formula for arc length S. See that? This is a radian, and this is the radius, which comes from our degrees formula. We've just simplified the degrees formula using the radian formula. Henceforth.
Also, by the way, in the MF19 formula sheet, they also give us this formula for r theta. For
yes.
the arc.
The formula booklet will give you these formulae in case you forget or something. But my teacher always recommends keep them safely secured in your head so that you can access them much quicker than if you want to flip through a book of formulas.
That is true.
Okay, this is the idea behind arc length. So let's just do practice questions. These questions should be like 30 seconds, under 30, well, 10 seconds even. So if we have a radius of 5 centimeter and an angle of 1 radian, what's the arc length going to be? Simply angle in radians, 1 times radius 5, which gives us 5 cm. That's the arc length. And what about this question? Well, you can see that the radius is 7 meter and the angle theta is pi over 3. Henceforth, our arc length here should be 7 times pi over 3. So we can simply write, in exact terms, 7 pi over 3 is our arc length. We'll cover more questions in the workout section. And now the sector area, which comes from the same idea. Now, if you take the area is equal to pi r square, and you take a slice of that, so like angle, slice angle out of the whole 360 degrees, like you're taking a slice out of 360 degrees, that'll give you the area of that sector, won't it? The whole circle's area times a slice out of that whole circle's area. Size of the slice difference. And again, thanks to our radian definition, this simply, which actually does this for us. So let's just write that here. Radian is angle 2 pi over 360. That's our radian, right? Radian. And we need to end up with this. It needs to be equal to pi r square angle over 360, which is our sector area definition. So what's the difference here? Well, I don't see much of a difference other than, well, r square. Yes, there's an r square here, so there should be an r square here. And one difference I see is that 2. There's no 2 over here, so I'm going to make it half. So if we simplify this to half radian, angle in radian, times r square is equal to the sector area. That's how the formula appears. The formula just comes from the radian definition. If you know the degrees formula and the radian definition, you can substitute that in and get it. Or again, you could use the given formula booklet, or you could simply memorize that. So let's look at a few questions. Question 1, what's the shaded area here? Well, we know the radius is 20 cm. We know the angle is that 11 pi over 6. So half times 20 squared, which is the radius squared, times angle 11 pi over 6, which gives us which gives us 1100 pi over 3, which you could simplify, times pi to 1152 cm cube square, because it's area. Or now let's do the same idea as the next question. It's a angle is 1 radian, radius is 1 meter. So half r square theta, half 1 square theta is 1, which simply comes out to half. The area of this sector is half a meter square. See how simple it is? It's just like, if you know the angle in radians and you know the radius, it's just like boom, you have the arc length and the area. And there's just a few more rules you need to know before you can start doing the funny circle stuff. And these we will have covered last year, hopefully. First of which is the sine rule, which works on any triangle. And as you know, if you're drawing a triangle, how to label it properly. Sides are labeled with small letters, A, and the angles are labeled directly opposite to them. So big A, angles are with vertices are with big letters. And let's call that B, side B, angle B, side C, angle C. I'm going to make it big C. Right, so the idea is ratio of this angle, sine this angle to length of this side A, side to angle sine. The ratio is constant. You can flip them, the ratio is still the same. Cosine rule. And wait, one more thing. If you use this, if you have two sides given, you have two sides, you have two angles, and one of these is what? No, one unknown. And cosine rule, this one, it's the relation between three sides, see just A, B, and C, and one angle. So three sides, one angle, and you have one unknown between these four. Again, that means this side length squared times this side length squared, this side length and this side square, minus 2 times side length times cos A. And this you can actually rearrange. I'm going to do that here. This important of the thing. If you know all three sides, but you don't know that angle, you're going to do this. I'm going to show you here. It rearranges, you can do basic algebra stuff. Square minus a square over 2bc equals cos a. So if you want to find out the angle a and you know all three sides, you can cos minus 1 here, cos minus 1 here to get a. So that's a little helpful tip with the cosine rule. If you remember three sides, one angle, and the area of the triangle rule. This works for, remember, these three rules work for any triangle. And this area rule comes from the triangle area, half BH. But instead of BH, we have half. If you have like A, B, you got an angle. And that's angle C. It's bound. What's the area of the triangle? Well, it's just side A times side B times sine angle C times half. This should all be review. So you should have already covered these. And here's some theorems which only apply to right angle triangles. Do not, I repeat, do not use these on non-right angle triangles. The Pythagoras theorem, this is a very common thing. You see, if you have the right angle triangle, A, B, C, hypotenuse is C, A squared plus B squared equals C squared, you know that, guys. And this right angle trigonometry, S, that's a horrible S. So, toa, this stuff. Tan is opposite over alternate. And what's this stuff mean anyway? Hypotenuse is H. And let's say we've given an angle on this side, theta. The one right next to the angle, you see right next to the angle, this is alternate. And the one opposite to the angle on the far side is the opposite. So that's how you use these. Again, this should just be a review. The sine ratios, you can use these. And now that we're equipped with these tools, the radian area stuff, sector area, arc length, we are now able to do the questions from the radian chapter. Okay, Ganesh, so please help us with this question. What do we do?
Sure. So it's asking for the perimeter of the shaded region, right? So automatically, the three sides that it's gotten is DC, CE, and DE, right? And DC and EC are basically arc lengths from these two circles. So my first task would be to find the angles of these sectors so that I can find the arc length, right? So what are we given? We're given that AC is 5 and CB is 8. So we could actually imagine this as a triangle of ADB. So AB is just going to be 13 units. Yeah, and we know that DA, that's also the radius of the smaller circle. So it's also going to be 5, right?
Mm-hmm.
So the two angles we need to find are DAB and DBA. So for DAB, it's just going to be, with our trigonometric ratios, it's going to be 5 upon 13 equals to sine theta. So theta would be equal to sine inverse of 5 upon 18. 13. Yeah. And then, wait, let's just see. That is equal to 0.3948. I would usually round it off to four significant figures. 3947. Wait, 48, sorry, yeah. If we round it off to
Wait,
four significant
DAB?
figures. Yeah, DAB angle, yeah. Actually, wait, no, wait, sorry.
This would
It
be
should have
cos,
been
right?
it should have been cos, yeah, true. My bad. So it'll be 5 upon 13 cos inverse.
Cos.
So that would be equal to 1.17 176. Yeah, correct. And then we need to find dba, right? So dba, I mean, I could automatically think that if we know that a triangle has 180 degrees inside of it, which is equal to pi radians, I could just do and we know that 90 degrees is pi upon 2. To make life easier, what we can do is we could do pi minus pi upon 2 minus 1.76 minus pi upon 2, which is 90
Wait.
degrees,
Oh yeah.
and then minus 1.176. So that would give us 0.3948. Yeah. So like this, we've gotten the two angles of the triangle, right? And they both basically are the angles for the sectors of both of the individual circles. So now it's going to make our lives way easier. So what's the formula for arc length? It's r theta, right? So in this case, it's just going to be 5 times 1.176 for DC. And then for EC, it's going to be 8 times 0.3948. Because the radius, the bigger circle is 8. And so for DC, that will give us 5 times 1.76. That would give us 5.88 for DC. And for EC, it's going to be 5 times 8. 8 times 0.3948. It's going to be 3.1584. 1584. Yeah, 84. And then we need to find one final length to find the perimeter. That is DE, right? So looking back at the triangle, right? We know what EB is. EB is gonna be the radius of the bigger circle. So all we need to find DE would be DB. Wait, to find DE, we just need to find DB, right? So looking back at the triangle, we know we've gotten two sides already, right? And it's a right angle triangle. And we've learned that with right angles we could use the Pythagoras theorem, right? So it's just gonna be 5 square plus b square equals to 13 square. So b square would be 13 square minus 5 square, and b would be equal to 13 square minus 5 square root. And that would give us
12.
That would give us 12, yeah. Exactly. And so if we know what dB is, right? That is 12 units. And we know what EB is, that is 8 units. We just need to subtract them both. So it's going to be 12 minus 8, that is equal to 4 for DE. So now we've gotten all of the three lengths of the perimeter. So adding these all, we get 4.8 plus 3.1584 plus 4, which is equal to 12.958. So like rounding it off, it's going to give us 13.0. Yeah.
Awesome.
And yeah. And now for the next question, it's gonna be this part of the same question because it's both part A and B. So in this case, they're actually asking us the area of the shaded region, right? And to do this, we would take the values that we have already gotten before, right? Which is DAB, angle DAB, and angle DBA, because we would be needing both of them in this case.
Mhm. So 1.176 and 0.3948.
Yeah. And so automatically what I get from the diagram is that it's a first of all a right angle triangle, right? And we have to find a small area inside of that. And there are sectors that make up the triangle. So what my immediate plan would be to find the area of the triangle and subtract the areas of the sectors to find the shaded region, right? So to find the area of the triangle, right? We've already gotten the values that we need, right? dB, that's going to be the height of the triangle, that is 12, right? So using the 1 upon 2 times space time height formula, it's going to be 12 times 5 divided by 2. And that will give us 30 units. Unit square, yeah. We can just leave it as it is for right now. And now we need to find the two areas of the sectors. And remember, what's the formula of the sectors? It is 1 upon 2 theta r square, right? And so for DAC, it's we're gonna get a 1 upon 2 times 1.176 times 5 square. And that will give us, let's calculate. It's gonna give us 14.7. And for the sector area of EBC, it's gonna be 1 upon 2 times 0.3948, I think.
Yes.
Yeah. Times 8, that would give us
It's square.
1.5792. Actually, no, wait. I need to calculate it again. I did not do the square. It's gonna be 12.6336. As we've already rounded off the radians, it's better to not round it off again. So, just in case you don't go too far from the actual answer. And so now what we have gotten is the area of the triangle, the area of the sector, and area of actually both of the sectors. So what we need to do is just subtract both of the areas of the sectors from the triangle to get the area of the shaded region. So it's going to be 30 minus 14.7
30
minus 12.6336. And that would give us an area of 2.6664, which we can round it off to 2.67. Yeah, that should be it, I think, for the area of the shaded region.
Let's check our answers. Yes. Awesome. 2.667. So let's look at the first question first. You can use either of the three trigonometric ratios. I'll give you a mark. You can get the angles. That'll give you another mark. You can get the length DE. That's the mark. The arc lengths are important. And the final answer, 13. Here, try getting the second question. You got the area, triangle, area of sectors, and subtracted them. One thing worth mentioning is that your calculator does have a way to that when you're doing trigonometric ratios like cosine or tan, their output can vary depending on whether you're in radian mode or degree mode. So your calculator will have a feature. It'll usually show you on top of your screen whether it's in radian or degree mode, indicated by a D for degree and R for radian. You can go to setup to change that and remember to change back. Because if you do sine, let's say 1, sine 0, sine 1, then sine inverse 1. Then you in radian mode, you look at half a radian, and in degree mode, you should be getting 90 degrees. So you see, you can get, it won't even show you the degree sign, it'll just give you 90. So it can get confusing when the numbers start looking small in radian mode. So and if you just don't want to do any of that switching modes, you can just do it in degree mode and then convert your answer to radians, but that's takes some time and might introduce errors. So I do suggest you switch to radian mode, do the trigonometric ratio, and change back if you need. So just make sure trigonometric ratios are affected by radian or degree mode because they're angles. Cosine works on angles, tan works on angles. So keep that in mind. Here's our second question. I will explain this one. The diagram shows a sector ABC. So this has the sector, right? And it has a radius of r. And the line BD is perpendicular to AC. Angle is in radians. Given that the angle is 1/6 of a radian, 1/6 pi radians, gives the exact area, means no like rounding or whatever, in terms of r. So using the variable r. And it's asking for BDC. So that means this area here. Now, in my mind, what I would do is I have a sector, I have an angle, looks like pizza. I'm going to take the sector area, and from the sector area, I'm going to subtract the triangle area. I'm going to be left with this bit here. So let's get the sector area first. And we know the formula for sector area is half theta r squared. So, henceforth, our sector ABC is equal to half times half 1/6 pi, that's our angle, times radius square in terms of r, remember. And for my triangle ABD, so that's the inner triangle here. We change color. This triangle here. For that, I'm going to use our trusty old sine rule, half. It's a half, by the way. Half sine theta times A times B. And so I know this is a radius, but I don't know what length this is. So what I could use is I could have gotten this length. That's not a radius. Length, let's call it. And done the sine rules that way. Or in other words, I could get this length, BD. I'm going to do the first way. I'm just going to get L. So using my trusty trigonometric powers, I'm going to go A, D, B, right angle. This is R. This is 1/6 of a pi radian. So what's this length going to be? I'm going to use, that's a hypotenuse, and that's an alternate. So I'm going to use cosine. Cos 1/6 pi. That's the angle, is equal to alternate, which I don't know, over hypotenuse, which I know, which is r. So henceforth, cos 1/6 times r is equal to my alternate, which if I put cos 1/6 pi to my calculator, it'll get, this becomes square root 3/2. Make sure you're in radian mode for this, equals L here. So this L is square root 3/2 radians long. No, radius is radii, no A. Henceforth, I can get the area now using half sine theta of ABD is half sine theta is 1/6 pi times side length 1 is r, side length 2 is square root 3 by 2r, which comes out to be r times r is r square. Sine 1 over 6 pi comes out to a half. It's actually this is just a half. So half times half, it's a quarter, times square root 3 over 2. Make sure you give them an exact form, so you don't want to put any decimals in there. You want to keep it in pristine condition. So that's square root 3 over 8, and radius times radius gives you radius square. So I'm going to change color again for this. ABD is this. Whole sector's area is this, which I can simplify to 1 over 12 pi r square. And so my exact area would be this area of the sector minus the area of the triangle. So my area would be pi r square, triangle, no, sector minus triangle. So cube root 3 over 8 r square, triangle. I could take out r common, but you don't have to because it's in terms of r. Just check that. Yes, sir. If you look at that. First thing, we got the sector area, pi over 12, 1 over 12 pi, same thing, r square. And then we got the BD length or AD, whatever. We found the triangle area, which simplified out to that. And we subtracted the two final. Correct answer. Okay, Vyomesh, please help us here. Given that this information, we need to find now the perimeter. How do we do this?
Sure. So it's talking about the exact perimeter of BCD. So for that, it's just gonna be BD plus DC plus the arc length of CB. And so to find DB, it's gonna be pretty much straightforward. Oh wait, it's already given, right?
Oh, yeah.
Oh, okay. So we have already gotten BD, right? We can find. Oh wait. So basically, in this case, the angle CAB is not given, right? So
Mhm.
I think it'd be better to find that first of all. Actually, wait, we don't even need to find it. My bad, my bad. We need to find DA to find CD, right? Right. We need to find DA. So to do
DA.
that, we could use the Pythagoras theorem because we've gotten already two sides. So it's
Oh,
just
yeah.
gonna be let's say if DA is B, right? Yeah. And let's say DA is B. So
Okay,
it's just
I'll
gonna
let
be
you.
B squared plus, or we could just do
R
equals to, yeah, sure. R square minus uh 3 upon, yeah, square. I was skip almost. And B would be equal to root of that.
Oh, yeah.
Yeah. And so that would give us root of R square minus that would be 3 upon 4 R square.
Yes. Wait, what? Minus 3
I think
on 2 square. So yeah, that just comes out to half r, I think.
oh yeah, it's just gonna be like it's gonna be R square minus root 3 upon 2 R would be 3 upon 4. So it's just gonna be 1 upon 4 R square and root that.
It's
Yeah. And so it's just gonna be 1 upon 4 root, so it's gonna be 1 upon 2 R. That's true. Yeah. And so when we've already gotten DA, we could also find CD, right? Because remember, CA is R, right?
Mhm.
And so it's just
Yes.
going to be r minus 1 upon 2r. So CD would be equal to 1 upon 2r.
Not the scale rule.
Yeah, it feels very different. That's why I don't go off the scale most of the time.
Mhm.
And now for CB, it's going to be pretty much straightforward. Oh, in this case, we do need to find the theta, right?
Mhm.
Okay, that makes sense.
So we need that arc
So
length.
yeah, we need the arc length. So I'll just go with cos. So it's just going to be 1 upon 2r divided by r would be equal to cos theta. And so r and r would cancel. So theta would be equal to cos inverse of 1 upon 2. That's also correct. Yeah, 1 upon 2 equals to cos theta. And so theta would be equal to cos inverse of 1 upon 2. And
Yes.
now we've gotten the r, we've gotten the theta. What do we do with it? To find the arc, we just multiply them together. So it's just going to be r times cos inverse of 1 upon 2, which is equal to pi upon 3. So it's just going to be, yeah, it's going to be pi upon 3 times r. This is going to be r pi upon 3.
Yes. Okay, so now we have all three sides. Now we just need to add them to get the perimeter. Woohoo.
Oh, yeah. Oh, okay. Wait, my bad. Yeah. I thought that was the final answer. Again, I did not read the question properly. So it's just going to be r pi upon 3 plus 1 upon 2 r. No, wait. Oh, wait.
Hmm?
Wasn't that 1 upon 2 r be something else? Oh, yeah. Wait, never mind. That's also correct. Yeah. I forgot the scale
Same.
issue. Yeah. And then it's
Scale
going to
skill
be.
issue.
And it's going to be plus root 3 upon 2r. Yeah, that should be it.
Let us
So that's pretty
check,
much it, I think.
check with the mark scheme, and yes, sir, that is
I
it.
think we have to just. Oh, yeah. Okay, that's true. That's fine then.
Or equivalent
Ye-
form.
Yay, let's go. We got it correct.
Okay, so you need the angle, you need the length of AD, so that length there, yeah, as we did, length of arc, and boom, we done did it. Okay, I will do this question. The diagram shows triangle ABC with a these sides are equal in length, and the angle is given. The arc CD is part of a circle with center A, center of the circle, and ABD is a straight line. Well, implied. So find the perimeter of the shaded region. One of the lines is already given, 6. So what we need to find is D to B and its arc length here. How are we going to do that? First, I want to find this side because that's going to be the radius of the circle in it. So when we're given two sides, we're given an angle. I want to find a side. So three angles, three sides. What am I doing? Three sides, one angle. What does that mean? This calls for cosine rule. A squared equals b squared. I think this is also given in the resource thing, formula booklet, right?
Can you repeat it?
Is the cosine rule given in the formula booklet?
I think not. I actually have it right by my side. Let me just check really quick without toppling some stuff. Let me just check. I don't think it is, but I would check. I don't think so, no.
Okay, so I guess you guys have to memorize this one.
Yeah. I think both the sine and cosine rules are not given in the formula booklet. I don't think so,
Hmm.
no. Yeah.
Okay, So we're using this side is A, and we want to find A. So I'm going to substitute in the other side lengths, which are 6 and 6, and the angle, which is 1.8, into this formula here, which I've written out. And that gives me the value of A, once I type this in into my calculator, minus 2 times 6 cos. Remember, you got to be in radians mode for this because angles in radian. A comes out to be 9.3999. Well, I guess that's just 9.4 then. Close enough. Okay, so this side is 9.4. 9.4 units. cm. Units are given. Cool. Find the perimeter. So why did I find this length? Well, because I want to find the arc. Also, I need to find this angle if I want to find the arc, don't I? So how do I find that angle? Now I have a triangle with 3 sides given, because I found all 3 sides. I know one angle, 1.8 radian. So I can use the sine rule now. See, this question uses all the rules. Look at this. Sine rule, which is, say, A over sine big A equals B over sine big B. And I want to find this angle. So I'm going to do this to this and this to this. So what I'm going to do is side length 9.4 over angle 1.8 sine 1.8 should equal side length 6 over angle theta. So sine theta. Let's cross multiply this, divide a bit, 9.4 sine theta equals 6 sine 1.8. And you get sine, I'm just going to skip a step, sine theta equals 6 sine 1.8, by the way, over 9.4 sine inverse. See how I got that? And when I type this in radians mode into my calculator, I will get an angle number. Let's see what it is. The big surprise. Theta comes out to be 0.6388. So 0.6388 is my angle there. Hence, I can find the arc length as r theta. R is 9.8, or 9.4, I mean, times 0.6388. Comes out to exactly 6.00. So I know that this arc length is now 6.0 units. One more thing remains. What's this length? Well, that's easy now, because I know that this is part of the circle. Hence, the radius on all parts of the circle is the same, also 9.4, because this AC is 9.4, so AD is 9.4. I know that BC is 6, so 9.4 minus 6 equals 3.4. So this is 3.4. BD is 3.4. So perimeter, I'm going to add all these lengths. So 6.00 arc length plus 3.4 BD arc and AC, which is 9.4. Comes out to a total of 6 plus 3 plus 9. 18.4 cm. Units are given, so you answer in cm, guys. Okay, that is what I have for
that
this
is
question.
not correct.
No?
No. I guess like
What
getting
happened?
6 is correct. 3.4 is correct. But AC might be incorrect.
Shall I consult with the mark scheme?
Oh, wait, can you go back? Oh, yeah. Could also do that, yeah. It wouldn't be that. Wait, let's see.
Something went wrong.
I think maybe with your arc. Are you sure it's 6? Because well, let's see. Let me calculate.
Yeah, it is.
I got 4. No, wait, no, that's weird. Wait, never
Is my
mind, wait.
angle wrong?
Maybe, possibly.
Oh, yeah. I could have done
It,
pi minus 1.8
yeah, it
radians
is
and divide by
wrong.
2.
Yeah, basically, because it's an isosceles triangle, right?
Isosceles triangle, yeah.
Yeah.
But yeah.
I did that calculation, I got something different. I got
Oh, yeah.
6.305.
Yep. Yeah, so this angle should have been 0.6708
Yeah.
because this is an isosceles triangle, so both these angles would have been the same. So we can just divide by 2, and which means only the arc was wrong. So let's redo the arc.
Uh, wait, I think looking at the mark scheme now, right? It
Uh-huh.
still would have been like, okay, you got the arc, right? Which is 6.306. You got okay, that's weird. 3.4 from the DB. Oh wait, yeah, but then you would have to remove the 9.4. It would be 6 because
Oh
it's an
yeah,
isosceles
bro, my
triangle,
gosh.
right?
Why am I adding 9.4?
It's not the radius
Bro.
that we're adding, it's the BC that we're adding, which is
Yeah, we should be
the
adding 6 plus this.
yeah. So that would
Okay.
give us 6.306 plus 3.4 plus 6.
So 12 plus
That would give us like 15.7. Let me just check if that's correct.
3.7. Yeah.
Yeah, that is correct. Yeah, from the mark scheme.
Okay. Okay, so pro tip, make sure you're adding the right sides on your perimeter, not the random sides that you decided to add. And also make sure you check your angles. So let's just copy over some values. 6, 8, this 6, 9.4. Yeah. Okay, go ahead.
Okay, so looking at the question, it shows that the diagram shows triangle ABC with AB BC equal to 6. It's already whatever we were given before, right? Here ABC is 1.8 radians as before. The arc CD is part of the circle with the center A, and ABD is a straight line. Find the area of the shaded region, right? So in this case, what I'm gonna do immediately is think of it as a sector and subtract the area of the isosceles triangle in the middle of it to find the area of the shaded region, right? And I remember there was this one formula that I did use a lot to find areas of triangles where two sides are given at an angle. It
Mhm.
was 1.2 AB sine theta.
Yes.
I
Sine
don't think
angle.
so. Like any other like formula book gives it out, but I've seen that in a mark scheme once, and I was like, that's a good formula to use,
It
right?
is.
Because in this case, one ways to do like get the height of it by dividing the angle, use cos sine whatever you want. It's complicated. It's just better to use 1.2 AB sine theta here. So in this case, the area of the triangle is going to be 1.2 times 6 times 6 times sine 1.8. And that would give us, let's see, 36 divided by 2 times sine 1.8. That would give us 17.53. Let's put it at 4 significant figures.
Okay.
And now we need to find the area of the sector, which is going to be pretty straightforward. We have already gotten one of we could get the angle BAC by, as we have done before, pi minus 1.8 divided by 2, because it's an isosceles triangle. And it was 0.6708, I think, yeah. And then we just need to multiply that by the radius, right? And the radius we already know that that's 9.4, so it's gonna be 1.2. Wait, yeah, times 9.4 squared times theta. That's gonna give us 29.64. And then what we have to do is just basically subtract these both values, right? So it's going to be 29.64 minus 17.53. That would give us a value of 12.1 for an area of the shaded region. Yeah. We could check it with the mark scheme too on the next page. And
Yes.
yes, that is correct. Let's go.
Sector minus triangle. See that half 6 AB sine theta formulas here. Awesome. And I think, how many more questions do you want to do? This one's simple. Point
This should be
P
quite
lies on
straightforward.
point on OC. BP is perpendicular to OC. Length is 2 cm. This arc is 2 cm. What's the angle BOC? Well, we know due to the properties of a radian that arc length, let's call this S, theta, and radius, r theta equals S. That's an 8. Where did fix yourself? Yes. Angle therefore is arc length over radius. So our angle here, B O C C. Wait a second. I've underestimated this. Okay, first we need to find angle this, then add it to angle this. But this angle is easy to find because that's what I've just mentioned. We're given the arc length. So 2 over radius is 10 equals 1/5 of a radian, 0.2 radians. That is BO. Okay, AOB, whatever. AOB. Add to that our AOC, which is 1 over 6 pi, totals to, it doesn't say give your answer in exact form, so I'm just gonna do like 3SF, let's say. And that totals to 0.10405 radians. Our angle BOC, so that's like the whole sector angle. And let us consult for, oh yeah, it has asked for exact angle, has it?
It actually asks for like just angle BOC, not exact. So that's something. But at the same time, can you go back to your working out? You got 1.5, right? Yeah,
Yeah,
it
we
was
did.
pretty straightforward. I think, wait, 1.6 times pi plus 0.2. I think you calculated wrong, like the 0.105.
Oh, I multiplied it, yeah. Instead of adding it by bad. So that will be 0.724
Yeah, it's just,
radians.
I think they also accept that in the mark scheme, so it should be fine.
Let's check it, yeah.
Or equivalent, yeah. That's true.
Yes.
That's fine.
So yeah, it doesn't specify for exactness. So that should be fine.
In questions, you need to make sure that they're not asking for an exact answer. And let me actually try to do this question for 7b. So it says that it's already the given information that we had in the previous question. Hence, find the area of the shaded region BPC, given your answer correct to 3 significant figures. BPC, that shaded region, right? So I'm just going to look at the area of the sector and subtract the area of the triangle. Simple as that. Pretty straightforward, right? So we've already gotten BOP as an angle, right? BOC, sorry. Or it's the same thing. And so let's just not like I think round it off. Let's just keep it in simple methods. It's gonna be 1.6 pi plus 0.2. And then what we're gonna do after that is to find the area of the sector, it's just gonna be 1 upon 2 times 10 square times 1 upon 6 pi plus 0.2. Let me calculate that. Times 100 divided by 2. That will give us 5 upon 3 pi.
Exactly.
Actually, wait, no,
Okay.
never mind. That,
0.2.
that wouldn't have been the case. I think I made the same mistake as you by multiplying both of them. Wait, plus 0.2 times 100
Sorry.
divided by 2. It'll be 36.18.
36.18. Okay.
Yeah. And for the area of wait, yeah, that's the area of the sector, right? So we need to find the area of the triangle, right? We have gotten I think one of the sides, right? We've gotten the angle. And so what we need to do is we could just find the bottom side, the base. And then we could just use the 1 upon 2 AB sine theta formula to actually find the area of the triangle. So
Yeah.
it's just to find the base, right? It's going to be 10 sine theta, sine of 1 upon 6 pi.
Cosine.
Oh, wait, my bad. Yeah, cosine,
Alternate.
yeah. Cosine, yeah.
Cosine.
Of 1 upon 6 pi plus 0.2.
Wait, 10 cosine.
Yeah, of 1 upon 6
Oh, yeah,
pi
okay.
plus
Experiencing
0.2.
input delay.
And that will give us, wait, let me just calculate. 10 times cos on 6 plus 0.2, not multiply. That will give us 7.494. And then when we multiply this by 10 and then multiply that by sine theta and divide it by 2, using the formula 1 upon 2, yeah. Let me just do that.
I'm not going to write out theta. 1 over 6.
0.6 plus 0.2. That would give us 24.8. And then with that, we have gotten two areas, right? To find the shaded region, we just need to subtract them from each other. So it's going to be 36.18 minus 24.8. That will give us 11.4 when we round it off to three significant figures. And there we go.
Voila, 11.4.
Nice.
You can admire the mark scheme. Whoa. Awesome. Okay. These are the last pair of questions. This one was interesting. The diagram shows two identical circles intersecting at points. Ta-da, ta-da. They're identical means their radius is the same. And their centers are P and Q respectively. The radius of each circle is R. The distance PQ is 5 over 5R. 5 over 3R. Find the perimeter and the shaded region in terms of R. So at first, you might not immediately know how to approach this, like the previous questions. So what we're going to do is we're going to split this in half, right? Just split this in half. And we're going to make that 5 over 6R on either side. And then I'm going to draw it like this. Watch. This is center Q of the circle. This is B. This is A. And if I draw a line like this, it's 90 degrees to them because A and B are intersecting vertically. This is horizontal. And the length from, let's call this, it's a nice letter, X. Okay. Let's call from point X to point Q, it's going to be, remember that 5 over 6R because we split in half. And we know that BQ is R. and AQ is r. Hence, we can find length this, and we can also find the angle this, which means now we can basically find everything. Okay, so let's do that. Find the perimeter. That means just the arc lengths. And both of the arc lengths will be identical. So we can just find one of the arc lengths and double them. So let's do that. I've already done it on Q's side, so let's continue on Q's side. Let's draw a nicer diagram. This is 90 degrees, remember. 5 over 6 r and r. It has to be in terms of r because we aren't given any numerical values. Plus it says in terms of r. X, let's just call that a. I'm going to find length a to x. Or I don't need to, that's completely unnecessary. I'm just going to skip that. Because I just want the arc lengths, don't I? So I'm just going to find the angle for the arc lengths. Right? And remember, it's also on the bottom. So actually my proper angle would be 2 theta for the big arc, all the way arc. So using my trigonometric powers, 5 over 6 r angle. This is a hypotenuse, this is an alternate. Hence cosine theta equals 5 over 6 r over r. R's cancel. Theta is 5 over 6 cos inverse equals. Make sure you are in radians mode, guys. I will keep saying this. Or you could be in degrees mode and convert, but that's up to you. 0.5. Hey, I remember doing this question in my last year. I recognize
That's
this
cool.
number value. Okay, so that's 1 theta. So we're just going to double that. Honestly, you don't even have to write it out. Just double it in your calculator to avoid rounding errors. That 2 theta is 1.171 radians. So we know that. I'm going to draw it on here for you guys, for your benefit. If we draw this angle here, this is 1.171. Given that information, we can now find this arc, which is going to be simply 1.171 times r is the arc. But remember, there's 2 of those arcs, so let's double this again. Times 2 is 2.234. Yeah, I'm going to leave it at that r. You could chuck in another 3 for fun, but 3SF is sufficient. So let us confirm whether this happens to be the case. Oh.
It is correct, yeah.
Yes. Yeah, 2.34. Okay, so now we're at the final question. And this is from the previous question, but instead of finding the perimeter, we're finding the shaded area. It's not immediately obvious, so can you help us, Vyumesh?
Sure. So what I immediately think of it is that I could actually put it as 2 sectors, right? Like, let me actually just draw a drawing of a sector first of all. So let's say AQ, or yeah, let's say APB, right? Yeah, that drawing. And then I'm just gonna draw a line from AB vertically down, right? So if I find the area of I forgot what do you call it. This AB is the chord, right? And what do you call the area that is outside of it?
Segment?
Segment, yeah, I think it is a segment, yeah.
I was
So
about to say ice cream cone.
it really does. So we need to find the area of the segment, right? If we find the area of one of the segments, we can just multiply it by 2 to find the other side too, right? And so to find the area of the segment, we need to find the area of the sector, first of all. And then after that, we could just subtract the area of the triangle. So for the area of the sector, it's just going to be r times 1.171, right? That's r. Wait, actually, no, my bad. I always get confused between the formulas. So it's going to be 1 upon 2 times 1.171 times r squared.
Oh, it's just r, yeah. Because r.
and that would be equal to 0.5855 r squared. So that is the area of the sector, right? If we're trying to find the area of the triangle, right? We're gonna use 1 upon 2 AB sine theta formula. Remember, it's very, very helpful. It's gonna save you a lot of time. So in this case,
Yeah,
yeah.
yeah. Carry on.
So in this case, we've got a like r as one side, r is the second side, and the angle theta 1.171. So it's just gonna be 1 upon 2 times um r times sine 1.171. Let me just do that. Sine that it'll be 0.4606.
0.4606 r squared.
Yeah, basically. And with that given, we could just subtract both of these values. 0.5855 minus this would give us 0.125. Actually, let's just put it as 0.49. 0.49. Oh wait, sorry. 0.1249 r squared. And now this is what we've gotten for one of the segments, right? So we multiply this by 2 to find the area of the shaded region. And when we do this, it's gonna be 0.50 r squared.
So this bit is this bit here.
Yes, basically.
Because we've taken the sector PAB and we've subtracted the triangle PAB from that. So we took, and since it's the exact same on the other side, except it just overlaps here like that, we're just going to double it as we said.
Yes, and that will give us 0.25 r squared. And we could also check this via the mark scheme.
So yes, indeed, 0.25.
Nice.
They suggest an extra 0 on the end for triple.
Oh yeah, true.
Significant figures.
I think it's like quite good practice to always go with like 3 significant figures, especially in our maths curriculum. It's always 3 significant figures for most of the questions, if not stated otherwise.
And remember, only round at the final stuff if possible. Don't round in between because you'll introduce uncertainty errors and stuff.
Exactly.
Okay. So that's all. Even if the question doesn't look immediately obvious, make sure you look at it from different angles, draw lines, do whatever you can, like mess around on the paper until something comes to mind. Okay. So that brings us to the end of this presentation. Thank you.
So thank you all for tuning in. I hope you had a great understanding of the topic. And if you want to get hold of the notes for this specific chapter, you could go over to the ZNotes website, and our social media handles are in front of you. So yeah, just feel free to drop any kind of questions that you might have, and see you later in the next upload. Thank you.